Okay, we're going to start looking at our properties of exponents. Our first property that we're going to look at is called product of powers. Now, product indicates that we have a multiplication problem, and powers indicates that we will have some exponents involved. This is what our product of powers is going to look like. We have a term times another term. So our basic operation going on here is the product. We've got the multiply problem. But now if you look within each term, we have some exponents. If we think about what 6 to the third and 6 to the fourth means in terms of multiplication, it means I have 6 times 6 times 6, so this first part represents my 6 to the third, and then 6 times 6 times 6 times 6, so the second one represents my 6 to the fourth power. Now if we simplify this, I actually have a total of 7 sixes. Well now, if you look back at what we started with, how could I use my exponents to get to this answer without having to write it out in terms of multiplication? Hopefully you've noticed that if you take 3 and add it to the 4, we get our 7. So when we have a product of powers, we can write it in terms of addition of our exponents. So take out your 8-page book and put this next example in it under product of powers. So we have b to the 5th times b to the 8th. So the first thing you want to do is make sure that you have the multiplication problem, which we do. And now we also have the same bases, just like we did up here. We had 6 and 6. Here we have b and b. So b to the 5th means I've got 5 of those b's being multiplied. B to the 8th means I have 8 of them. So my final answer for this would be b to the 5th plus 8, which would be b to the 13th. Our next one we're going to look at is called power of power. So it looks similar to product of powers, but this one is power of powers. What this means is I have an exponent of something that already has an exponent. And it's going to look like this example right here. We have 2 to the 4th raised to the 3rd. Well, if we think in terms of multiply, the 2 to the 4th is really 2 times 2 times 2 times 2. And I have that raised to the 3rd power. So that means I have this group of 2's 3 different times. Now if we go through and we count all these up, I'm going to end up with a total of 12 of these 2's. So I'm really going to end up with 2 to the 12th. Well, if we look back at the numbers we started with here, the 3 and the 4, we can get a 12 from those without having to write out all this stuff in between by multiplying them. So when we have a power of a power, we multiply our exponents. So we would have had 2 to the 4 times 3, which is how we got our 12th. So now in your 8-page books, put this example in there. If we have k raised to the 5th raised to the 6th, I'm going to multiply my exponents. So it's going to be k raised to the 5th times 6, which would give me k to the 30th. Now notice the differences between our product of powers and our power of powers. The power of powers, the exponent is on the outside of the parentheses. With the powers of powers, each individual term has its own exponent. Okay, now another one is called the power of a product. The one on the first side was a product of a power. This one we're doing power of a product. What it's going to look like is we have a product. We have something inside here being multiplied, and then we have an exponent on the outside. So we're taking the exponent of some type of multiplication problem. Well, if we write this out in terms of multiply, we would get 5x times 5x times 5x, because that's what the 3rd power tells us to do. We can simplify that down even farther. I've got 3 5's here, and I've got 3 x's. So each of them can be split apart into their own exponents. I've got 5 to the 3rd, and then x to the 3rd. Well, if you look back at our original problem, it's almost like the distributive property. Each piece inside the parentheses gets the exponent. So the 5 gets the exponent and the x gets the exponent. If we were asked to simplify this actually all the way out, we would have to multiply out the 5 to the third, which is 125, x to the third. So now in your 8-page books, under power of a product, go ahead and put this example. The quantity 2xr, all of it raised to the fourth. And now if we think in terms of the distributive property, everything inside here has got to get that fourth power. So I would have 2 to the fourth, x to the fourth, and r to the fourth. Then I would multiply out my 2 to the fourth, which is 16, so I would end up with 16x to the fourth, r to the fourth. Okay, our next property we're going to look at is the zero exponent property. This one will make more sense when we get a little bit farther into the properties, but for now just trust me that this is how it works. If I have 8 raised to the 0, I'm going to get a 1 back. If you don't trust me, take your calculator out, type in 8 to the 0, and it will give you a 1 back. If I have 5 raised to the 0, you're going to get a 1 back. Any number that you have raised to the 0 is equal to 1. So in your 8-page book, go ahead and put x to the 0 is equal to 1. If you want to put a little note beside it that says any number raised to the 0 is equal to 1. That way it might remind you. So here's going to be some practice problems. Go ahead and pause the video and see if you can simplify the following. Okay, the first one here was the product of powers property. So I had different terms being multiplied together and there was some exponents involved. Now they all are x's, so I can go ahead and combine them all, and I do that by addition. So I would have 4 plus 7 plus 3, which gives me x to the 14th. The one down below actually ends up combining 2 of them. It's the product of powers, and then we'll use the zeroth exponent property. Now if you look at our product of powers, one thing that you have to understand is in this first x, even though you can't see an exponent there, there's a 1 there. Because if I didn't have anything, I wouldn't have that x. So I've got 1x there, 3 of them here, and negative 4 of them here. Well, when I apply my product of powers rule, 1 plus 3 plus negative 4 gives me 0. So I end up with 2x to the 0. Well, the zero product property tells me that anything raised to the 0 is 1, so I get 2 times 1, which gives me just a 2. Okay, the third one you might have been a little stumped on. We're going to use the power of products and the power of a power at the same time. So I'm going to start with my power of power, and I know that each of these needs to get the 2. So I'm going to have 8 squared, and then this x to the 6th also gets squared. This is where the power of power comes in. The 8 squared I'm going to go ahead and change into a 64. Now when I have x to the 6th raised to the 2nd, this is when I multiply my exponents. So I would end up with x to the 12th. So for this last one, I have 64x to the 12th.